Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about one of the strangest realms in all of science, the quantum theory. And we'll ask a question: is it possible to be dead and alive at the same time? Is it possible to walk through walls? Is it possible that time can speed up and slow down? Well, normally you would say, bah, humbug, that's ridiculous. That's the stuff you see on Twilight Zone. But that's the world of modern physics. Now, why should you care? Because our entire society is based on quantum physics. The transistor, the computer, the internet, the laser, all of them are based on this bizarre theory that violates everything you know about common sense, about being two places at the same time, about being dead and alive simultaneously. Well, with us today to wade through some of this is a physicist, Professor Paul Halpern, Professor of Physics at the University of the Sciences in Philadelphia, and author of a series of books, Synchronicity, the epic quest to understand the quantum nature of cause and effect, about the physicist Wolfgang Pauli, and also the psychoanalyst Carl Jung. And another book about Richard Feynman, The Quantum Labyrinth, how Richard Feynman and John Wheeler revolutionized time and reality. So once again, today we're going to discuss the nature of reality itself. What is real? And why should you even care, given the fact that modern technology, the internet, telecommunications, GPS, laser beams, satellites, all of that depends upon this bizarre theory called the quantum theory. Well, with us today, once again, is Paul Halpern, Professor of Physics at the University of the Sciences in Philadelphia, author of the book Synchronicity and the Quantum Labyrinth. Well, Paul, let me ask you a question. When you were a young kid once, what first got you interested in science, and in particular something as abstract as physics?
Well, when I was a child, I discovered, first of all, that I was pretty good at mathematics, but I was also fascinated by nature and fascinated by the universe. And what sparked my interest was reading a lot of science fiction. I read people such as Isaac Asimov and Ray Bradbury and started to dream about other planets, other worlds, other possibilities. People like Robert Heinlein, who described a four-dimensional house and things that seemed crazy. But then I started to realize that there were theories in physics that matched up with some of these ideas, matched up with ideas that the world is four-dimensional, including time. And I began to look into some of these things. Also went to a lot of museums, and that sparked my interest in physics as well.
Okay. Well, now let's talk about the quantum world. Quantum is a sexy world. There's even a bank with the name of quantum. There's quantum technologies, quantum stocks, quantum medicine. And if you're into New Age, everything is quantum. But let's talk about, well, what does it mean and why did you write books about it? First of all, we have the common sense world. The common sense world says that you cannot be two places at the same time. Duh. That's just common sense. Common sense says you cannot be dead and alive simultaneously. Common sense says you cannot walk through a brick wall. That's the Newtonian world. That's the world called objective reality. The common sense world that a rock is a rock is a rock. Now, explain to us how the quantum world differs from the common sense world of objective reality, and why should we care?
Well, Isaac Newton in the 18th century came up with a series of equations that describes how particles move, how they interact along with forces. So if you have a set of particles and you have forces, which are pushes and pulls that affect the particles, you can predict what happens to those particles. Now, shortly thereafter, a French mathematician named Pierre Laplace came up with something called Laplace's demon. So this demon is not a real creature or a horrific creature, but rather a thought experiment, imagining a demon that knew somehow all the positions and the speeds of everything in the universe at one time in its history, just 1 second in its history. That demon, in theory, should be able to use Newton's laws to predict every other moment in the universe, predict the entire future of the universe. And that was extended in the 19th century by psychologists into something called psychic determinism, which said that perhaps you could even read people's minds if you knew all the particles in the universe. You could predict everything, not just in the world of matter, but in the world of the mind. But there's a flaw with that, actually 2 flaws. One was discovered in the past few decades, and that's called the butterfly effect, that you can have a system of equations that is very precise, but somehow if you plug in just a slightly different initial condition, meaning a slightly different starting number, you get very, very different results. And that's called the butterfly effect because imagine something like the weather being affected by the flapping of a butterfly's wings if the equations are sensitive enough. But an even stronger objection to the Newtonian world is the world of quantum physics, which is only about 100 years old, less than 100 years old, but it was a remarkable revolution in our understanding because it said that things like position, location, and speed are not fundamental. They're not built in, but rather they're things that you measure, and you can only measure them with probability, not exactly, and those measurements come from something called a quantum wave function, which is the fundamental thing. And the quantum wave function is a bit like a black box. You don't know what's inside it. You can only tap on it and try to figure out what the results are if you take particular observations. But you can't always take all the observations, all the measurements precisely at once.
Welcome back to Science Fantastic with Professor Michio Kaku. Today we're going to talk about the most bizarre theory in all of physics, but it's a sexy topic because lots of things are named after it now. You can't go into a New Age store without bumping into quantum therapy, quantum healing. In banks, there's even a quantum bank, for God's sake. But what is the quantum anyway? On one hand, we have the Newtonian world, the common sense world. The common sense world that says that you cannot be 2 places at the same time. You cannot walk through a brick wall. You're either dead or alive. Period. End of story. Well, then there's Heisenberg uncertainty, that you really don't know the location of an electron. Probabilities were then introduced in physics, and Einstein hated that concept. God does not play dice with the world, he said. Well, apparently Einstein was wrong. Transistors, lasers, the internet, GPS, all that depends upon the quantum theory. And to understand the quantum theory, it's good to understand the cat problem. So where we left off, we were just beginning to discuss with Paul Halpern, author of the book Synchronicity and the Quantum Labyrinth, the cat problem, which was originally devised by Schrödinger to demolish this probabilistic interpretation, but it really goes to the crux of the matter. How can you be dead and alive simultaneously? So, Paul, explain to us the cat problem.
So Schrödinger imagined an absurd situation in which a cat is placed in a box along with a vial of poison and a Geiger counter which detects radiation and a radioactive sample that would decay with a certain probability, let's say 50%, within a given amount of time. So it had a 50-50 chance of decaying. Now, in quantum physics, that seemed perfectly normal for a radioactive sample or something very small in the particle world to be in a situation where it had a 50-50 chance of being decayed or not decayed. And we call that a superposition, which is a mixture of states. So the radioactive sample is a mixture of decayed and not decayed until we take a measurement with the Geiger counter. Well, Schrödinger added the fact that the Geiger counter would trigger the vial of poison to be broken and released to kill the cat. Now, everything is placed in a closed box, so nobody takes an observation. So Schrodinger said until somebody takes a measurement, they don't know if the sample is decayed or not decayed, so it's in a mixed state. Therefore, the cat is in a zombie-like mixture of being alive and dead until we open up the box and take a measurement. Now, Schrodinger was not cruel to cats. In fact, he didn't have a cat. He actually had a dog. But Schrodinger didn't have a hatred of cats. He just liked to come up with the craziest situations to show people so that they would say, aha, quantum mechanics must be incomplete. Well, the surprising thing is that quantum mechanics is complete, and it's very predictive, and that Schrodinger was wrong that quantum mechanics is right in terms of predicting superpositions. But the reason, yes.
Now, Einstein hated the quantum theory because he said that the cat is either dead or alive, independent of whether you open the box to take a look. The quantum theorist said that before you open the box, the cat really is in a state of neither dead or alive. So then the question is, well, if a tree falls in a forest and there's no one there to observe the tree or hear the tree fall in the forest, maybe it didn't fall at all. Maybe the hearing process determines whether the tree fell or not. Well, most people think that's a stupid philosophy. Of course the tree fell. It either fell or didn't fall. But the quantum theory is worse. The quantum theory says that if you can't watch the tree could be in any possible state. That is, toothpicks, a log cabin, plywood, crushed, burnt, ash. Before you look at a tree, it could be in any state, and when you look at the tree, it suddenly becomes a toothpick, many toothpicks. So, how do you resolve this question?
Well, Einstein tried in his later years to come up with a theory of everything that would supersede quantum mechanics and explain everything deterministically. That is, going back to the Newtonian idea that the past, present, and future are all connected without probability, because he hated the idea of dice rolling. But unfortunately for him, and fortunately for quantum measurements, there is dice rolling involved. And the other thing that Einstein didn't like was the idea that particles would not know what they are and how they were about to be measured until the measurement is taken. He thought that a particle should know instantly that it's in a certain position and a certain speed until a measurement's taken. Well, that turns out not to be the case. You have to take the measurement first, and then suddenly the particle instantly knows what position, state, or what speed it is because of the type of measurement that's taken, which is very, very strange.
Now, why should someone who is into philosophy and new age even care? Because there is another interpretation, which I don't necessarily adhere to, but the other interpretation is that observation determined existence. Observation requires consciousness. Therefore, there are some people, and I don't necessarily agree with them, that say that consciousness determines existence, that our very consciousness, our thinking, our desires, we can make, in some sense, wishes come true. Now, isn't that a distortion of the cat problem?
I think that is a misinterpretation of quantum physics because, first of all, quantum physics takes place on a particle level, and it is very strict in terms of what measurements can be taken, what measurements cannot be taken, and what the results will be. So you have a fairly predictable range of results. You don't know the exact result, but you have a range with a certain probability. So it doesn't exactly say that anything can happen. So if you wish something, it might happen. That's not what quantum mechanics is saying.
Okay, now let's talk about Carl Jung, the famous psychoanalyst along with Sigmund Freud. And he believed in something called synchronicity. And usually in physics we have something called cause and effect. But if everything is probabilistic, then the question is cause and effect also probabilistic? And synchronicity is when you, let's say you think of somebody like Joe, and all of a sudden Joe calls you on the telephone, and you say to yourself, I was just thinking about him. Is that a coincidence? I think about Joe, and he calls. I'm psychic. So tell us now about the concept of synchronicity and the cat problem.
Well, Carl Jung was a psychoanalyst, and he broke with Freud because Freud thought that things happen to the individual, and Jung's innovation was something called the collective unconsciousness. He thought that somehow people's minds are linked up in some manner, perhaps through evolution or some commonality. But Jung was spurred into thinking about these ideas by meeting with Einstein in the 1910s in Zurich. They both lived in the city of Zurich. Einstein was teaching there briefly, and Jung was a psychoanalyst there, and they had discussions, and Jung realized that general relativity allows for signals that not only to go into the future, but you could theoretically have signals going into the past if you set things up right. We haven't seen those things, but theoretically that could be possible. So Jung wondered if you could have interactions that happen simultaneously rather than taking time, and that spurred him to think about synchronicity and other ideas.
So in your book, Synchronicity, you talk about Carl Jung, the philosopher and, of course, psychoanalyst who believed in synchronicity, but a hard-nosed physicist called Wolfgang Pauli also shared some of these ideas. How could that be?
Well, Pauli was notorious for being very hard-headed and very critical, and he was nicknamed the Horrible Pauli or the Scourge of God by one physicist because he was always critical of other physicists' theories. But ironically, he met Jung and he turned to mystical ideas, which is very strange. But what happened was, around 1930, he had a life crisis. A few things happened to him which jolted him, and he was very sensitive inside, and these led him to seek psychoanalysis, and the psychoanalysis was with an assistant of Carl Jung and eventually with Jung himself. And the jolting events that happened to him is, first of all, his father had an affair, and his mother committed suicide, sadly, and then Pauli got married, and his first wife was in love with a chemist, and Pauli knew that when they got married, but she continued to see the chemist, and then finally they got divorced after only about a year. And Pauli said, if she ran off with a bullfighter, I'd understand that, but running off with a chemist, my God. So that made him very depressed, especially about women, and he sought counseling, and his meeting Jung led him to discover synchronicity and some of the other ideas of Jung.
And so what was Wolfgang Pauli's thinking of synchronicity, which defies the usual understanding of cause and effect, which in turn is the foundation of all of science?
Well, Pauli believed strongly in the idea of symmetry. Things can be connected not just through cause and effect, but through symmetry. So an example of that is a mirror image. If you're standing in front of a mirror, then there's a mirror symmetry, so the reflection looks exactly the same as you. So if you do something, your reflection is doing exactly the same thing. And that kind of symmetry happens in the particle world.
Then the next question that a lot of people ask is Elvis Presley still alive in another universe?
Well, strangely enough, there are theories of what's called a multiverse or parallel universes. And there are many different types of those kinds of theories. But one of them is in quantum physics, and that's called the many worlds interpretation of quantum mechanics. And that was developed by a graduate student of John Wheeler who heard a talk by Einstein. And Einstein asked the question, in quantum physics, what if a mouse takes the measurement? Should that give you a result just like a human? And Everett was so stunned by that question that he began to challenge Niels Bohr, who was one of the fathers of quantum mechanics, and say, well, maybe you don't need an observer. And he tried to think of a way around it. And the way he thought is that every time there's a measurement, the universe splits into many different copies of itself, and the human mind splits as well, so that you have somebody thinking that they're in one of the parallel universes, while another version would think that they're in another of the parallel universes where a different outcome occurs. It's mind-blowing, and many physicists don't believe in it, but there are a sizable minority who do believe in that idea.
Okay, well, on Science Fantastic, we had a Nobel Prize winner, Steve Weinberg, on the show, and I asked him that question of, can you be dead and alive simultaneously? And he answered the following. He said that, well, in our world, everything vibrates. For example, a radio is tuned to one frequency, but there's all these vibrations of all the other radio stations in your living room, but your radio is only tuned to one frequency. So he says that in your room, we have all the wave functions of all possible universes, dinosaurs, pirates, space aliens, all these bizarre wave functions in your living room, but you're not tuned to them, that you're not vibrating at the same frequency. Therefore, you have decohered. You cannot enter a world of dinosaurs because we no longer vibrate at the same frequency. So in other words, in one frequency, Elvis Presley could still be alive, but you can't talk to him. You cannot interact with him because we are vibrating at a different frequency. So he believed in a many worlds interpretation. I work in string theory, and string theory in turn is defined in the multiverse. But what are your thoughts?
Well, I know that a lot of theorists are very excited about the possibility of many worlds or the idea of a multiverse, just because it resolves a number of questions that are theoretical. For example, you don't have to have a human observer. Everything just happens on its own. Everything flows. You just have, instead of a single flow, like a single river, you have branches, and those branches continue without any interruption. So nobody has to take a measurement. So that makes sense because it's self-consistent. And I once talked to another well-known physicist, Bryce DeWitt, and he said, well, that's the only game in town because otherwise you need to add in humans into the mix, and it doesn't make sense. On the other hand, when he first confronted Everett's ideas, he was blown away by the multitude, how many different universes you would need. You would need billions and billions of possibilities of different types of universes that would be very, very slightly different from each other.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Paul Halpern, Professor of Physics at the University of the Sciences in Philadelphia, author of a new book, Synchronicity, The Epic Quest to Understand the Quantum Nature of Cause and Effect, and another book, The Quantum Labyrinth, How Richard Feynman and John Wheeler Revolutionized Time and Reality. Well, we talked about the many worlds theory, which is gaining more acceptance. I personally believe in the many worlds theory, working in something called string theory, which gives you a landscape of possible universes. But there's another point of view. To the extreme, the other point of view was given to us by Eugene Wigner, winner of the Nobel Prize, one of the fathers of the atomic bomb. And Eugene Wigner says that if you need an observer to establish whether or not a cat is alive or dead, then who establishes the observer? Well, somebody has to look at you. Somebody has to look at you looking at the cat to determine that you exist. Well, who looks at the observer? Somebody looks at him, looks at him, looks at him, looks at the cat. But who looks at him or her? In fact, you get an infinite sequence of observers watching observers watching observers until finally one of them looks at the cat. And then he says, who puts the whole thing together? Some kind of God. And so Eugene Wigner dabbled in Indian philosophy and came up with cosmic consciousness that makes the cat alive or dead. So what do you think about the opposite point of view? On one hand, we have many worlds, an infinite number of parallel universes. On the other hand, we have an infinite number of observers going all the way out to God. What are your thoughts?
Well, a number of quantum physicists wrestled with that question in the 1920s and 1930s, and not just Wigner, but also Niels Bohr and many others, John von Neumann. They wondered if we could somehow separate the world of the observers from the world of the quantum. And unlike Wigner, Niels Bohr, whose philosophy became known as the Copenhagen interpretation, said, well, perhaps we can talk about observers living in a kind of Newtonian world, in a world in which cause and effect operates, and that the quantum world is kind of a black box that's mysterious, but we should not really probe it, just look at what kind of results we get and divide the two things into the world of consciousness and human observation and the material world. But Pauli himself, along with Jung in his discussions, thought that perhaps there needed to be a unified theory of not just matter, but also the mind, that perhaps somehow the universe and consciousness needed to be explained by a single theory that explains how consciousness is connected as well as material things are connected in a kind of entanglement or long-distance connection between things.
So what do you think? You've interviewed a lot of physicists for different points of view, all the way from Eugene Wigner's point of view of a cosmic consciousness, all the way out to the many worlds theory of an infinite number of parallel universes. What are your thoughts in terms of where most physicists are? Are some physicists simply just people like mixing a recipe in a cookbook? They don't care where the cookbook came from. They just use the cookbook. What are your thoughts?
Well, I strongly believe in the scientific method, and I know that quantum physics is very successful in explaining technology and in explaining the world around us, and it's extremely useful. Things like superconductivity, the laser, quantum tunneling, and explains so much in nature. And science is getting better, and experiments are getting more and more precise. So what I see as the future is being able to test all of these possibilities using highly precise quantum measurements to be able to track things down to a mere fraction of a second, a fraction of a nanosecond, and to try to track exactly what's happening when you take a measurement of a particle. And excitingly, there are physicists out there who are trying to track things that were thought to be spontaneous and actually finding that they can plot what happens during quantum transitions and see it on a screen and say, well, okay, well, that's what's going on there. And I think that within the next couple of decades, we'll be able to distinguish between the different possibilities and come up with a theory of what happens when we take a measurement of a quantum phenomenon. So I think it's going to come from very, very careful observations.
Well, we're running out of time, but let me ask you a quick question about entanglement. Synchronicity, of course, goes to the heart of cause and effect. But in quantum theory, if I have two electrons and they vibrate together, they're very close, they vibrate in unison, and separate them, there's an umbilical cord. An umbilical cord that emerges, which is invisible, connecting the two electrons that used to be vibrating coherently in phase. And if you separate them to the ends of the universe, if you touch one, the other one in some sense senses that its twin is also being touched, and that sensing can travel faster than the speed of light. Well, Einstein, of course, hated that idea, but the experiment has been done, and Einstein was wrong. So explain to us a little bit about entanglement in the last few minutes that we have on Science Fantastic.
Well, that's real synchronicity, and Einstein derided that as mind reading, but that actually happens. Einstein came up with a thought experiment where you take two electrons that are in the same state, the same location, and we know that the two of them must have one difference, and that difference is called spin, which is how the electron faces when it's in a magnetic field. So one might be spin up, the other spin down, but until you take a measurement, you don't know what their spins are. But if you separate them widely, if you measure one of them as being spin up, the other one must instantaneously and automatically be spin down.
Okay, Paul, unfortunately we have run out of time, but thank you so much for being on Science Fantastic.
My pleasure. I really enjoyed it.